Hello everyone. A very good evening to one and all of you. I hope I'm audible and visible. So if not, any one of you can confirm it. Okay, so everyone is joining currently the session. So we will start in some time so that everyone can able to join this session. So, okay, let's start the session. So, hello everyone, a very good evening to one and all of you. So, my name is Pooja Verma. I'm PMRF Research Scholar from IIT Kharagpur, and the instructor for this course is Dr. M.K. Bhuvan, Professor in the Department of Electronics and Electrical Engineering, IIT Guwahati. This is a week one live and interactive session on computer vision and image processing, fundamentals and applications. So, I hope you have gone through this week video lectures, right? And any one of you can you please confirm it whether I'm audible and visual? And for asking and interacting, you can use chat box. A lot of background noises are there, but here it's clear. Anyone else? Okay, anyone else? If anyone have any other problem? So it's clear or not? Okay, okay. So people are joining now. So let me- is it audible now? Okay. So this is a course layout for this course. I think all of you have gone through this course layout as well. So in the first week, you must be gone through the introduction to computer vision basic concept of the image formation. In the next 2 weeks, we will gone through the fundamental concept of the image formation, and in the next upcoming other weeks, image processing concepts, image descriptors and features, and then fundamentals of the machine learning, then basically applications of the computer vision. So here we will solve some questions which will be very similar to your assignment problems so that you can able to solve the assignment questions. Okay, so these are the some text books and references you must have. I think you have gone through these books and you must have that one. Okay, let's start the some questions. So here we will go through some basic concepts of the linear algebra, probability, and image formation. Then we will move to the some more questions as well. So, any one of you have any idea how to solve this problem? This is a basic linear algebra questions. So you have to interact here as well. So the first question is for what value of x will the matrix given below become singular? So the matrix is given for what value of x the matrix will become a singular matrix. Anyone? How to proceed with this question or how to solve? So as we know that a matrix is singular if its determinant is 0, right? So here we need to find out the determinant of this matrix. So can you calculate the determinant of this matrix? So this is a 3 cross 3 matrix, right? So how we can calculate of the determinant of this matrix? So here for this one, here you 8 common, then 0 minus 12, right? And minus x, this column in bracket, 0 minus 24, plus here it will get a 0 because the common part is 0. Okay. So here you will get minus of 96. Here you will get plus 24x, right? Because here minus and minus will be the plus one. Now, if you equate this one, so you will get 24x is equal to 96. Here, a matrix will be the singular matrix if its determinant is equal to 0. So, all we need to put here equal to 0, right? So, here it is already equal. We have taken this one, so not required. So, if you just solve for the x value, 96 divided by 24, if you further divide it, so you will get value of 4, right? So which option is the correct one? Option C is the correct one for this question. Yeah, determinant is 0, yeah, right. Answer is 4. Is it fine for you? Okay, so option C is the correct answer for this question. Now we will move to our next question. So here already solution is given, then you will see it later also. So already we solved this problem here. Now our next question is, if A is a real square matrix, then A transpose is. Option A is unsymmetric, or option B is always symmetric, option C is skew symmetric, or option D is sometimes symmetric. Which option can be a correct one? Always symmetric, okay. So let's see detailed solution for this question. So if A is a real square matrix, then A transpose is always a symmetric matrix. Thus, this one is correct. But how? So we will see here how. So that means it is equal to its own transpose. So if we take a transpose of this matrix, A, A transpose of the transpose, then we will again get A transpose, right? That's why it is always symmetric matrix. So this property holds because of transpose of the product is the product of the transpose in the reverse order. So here if we are taking, so if just you open this bracket, so you will get A transpose because it is in the reverse order. Transpose into A transpose, right? Then again A transpose is A only. So A transpose you will get again. So since the transpose of the matrix equals to the matrix itself, so A transpose is always a symmetric matrix. Okay. So option B is the correct answer. Yeah, right. Many of you have given the Right answer? Typing is very loud. No, no, it's far away from the mic. So anyone else also getting any facing any issue? So when I'm just downing the volume, then it is most of the people are not able to listen when I am just okay. Okay, so here option B is the correct answer. So now I think the explanation. Have you listened about the explanation? So have you understand why A is a real square matrix, then A transfer is always a symmetric matrix? Okay, so here again the detailed description is given, so you can see it later also. So now moving to our next question. So now our next question is, let A be a 3 cross 3 matrix with rank 2, then A x is equal to 0 has option A only trivial solution x is equal to 0, or option B is one independent solution, option C is two independent solution, or option D is a three independent solution will be there. So which option can be a correct one? Please try to answer for this question. And I think all of you have must have gone to the week zero question assignment problems, week zero assignment problems. Have you tried there? One independent solution. Okay. Yeah, right. So can you explain it little bit? Yeah. Anyone else? Any answers? Okay. Yeah. Right. Pinky. So we will see here. So for any matrix M cross N, let's say here, but it is given 3 cross 3 matrix. So for any M cross N matrix, M cross N matrix, so the to find out the here, because the matrix is not given here, rank is given, and what is the dimension of the matrix, it is given, that is a 3 cross 3 matrix, right? People are still joining, so yeah. So how we can find out the how many solutions will be there? By using the rank nullity theorem. Okay, the rank nullity theorem. So what is the rank nullity theorem? So rank nullity theorem states that any matrix having rank rank of a matrix A, then plus nullity of that given matrix. So here A is the matrix, okay. Then here equal to n, that is number of columns here. So here rank of the matrix that is given, that is a 2. Rank of A is given, that is 2. And already we know that it is a 3 cross 3 matrix, so 3 rows and 3 columns will be there. So here n is also given, n is equal to 3. So now put into the rank nullity theorem and then just calculate it. So if you put here rank is 2 plus nullity of A is equal to 3. So here you will get nullity of A, 3 minus 2 will be 1. So that means one independent solution will be there. Okay, one independent solution will be there. So yeah, option B is the correct answer for this question. Okay, so have you understand this question, all of you? Okay, right. Very good. So now moving to our next question. Our next question is the eigenvalue of the this matrix are. What is the eigenvalue of this matrix? So here rows and columns are the identical because all values within the matrix is 1, right? So how we can find out the eigenvalues of this matrix? Can you solve this question at least? Okay, matrix minus lambda into identity, okay, equal to 0. Okay, so can you solve it and give the answer in the chat box? Which option can be a correct one? Okay, option C, correct. So have you solved this question over there? So yeah, one way to solve, like Minad, I think, have given in the chat box. The other way we can also solve. Okay, so this is the all ones matrix, right? The all values of the within a matrix is 1. So and all the rows are also identical to value 1. So the matrix of the rank would be 1 only because the rows are the identical, right? All rows are the uh, identical. So the rank of the matrix is 1. And for any n cross n matrix, the number of eigenvalues is equal to 0 if at least n minus rank of a matrix, let's say rank of it. This is a matrix A, let's say, okay. N minus rank of A is there. So here N is 3 cross 3 matrix it is. So N will be the 3 only. So 3 minus 1. So total number of 2, at least 2 eigenvalues would be the 0. At least 2 eigenvalues are 0. Okay. So now next the 2 eigenvalues, let's say lambda 1 and lambda 2 are 0. So how we can find out the lambda 3? So that can be find out using the trace of the matrix, using the trace property. Okay. So the trace of the matrix can be calculated because all values are the identical and 1. The trace of the matrix, I already that it is defined as the sum of the all diagonal elements and is equal to sum of the eigen values. So trace of the matrix A is calculated by all the diagonal values. This one. So all the values are 1. So 1 plus 1 is equal to 3. Right. So sum of the eigenvalues, that is lambda 1 plus lambda 2 plus lambda 3 is equal to 3. We have got, that is a trace of the matrix. Here already we have seen that if the rank of the all the rows of the matrix is identical or equal, so the matrix is defined by the n minus of rank A. So that means 3 minus 1, that has a two eigenvalues are the 0. At least 2 eigenvalues will be the 0. So already we have seen that first two eigenvalues are the 0. So 0 plus 0. So lambda 3. So lambda 3 you will get here 3. And already lambda 1 and lambda 2 are 0. So the values, so eigenvalues are the 0, 0 and 3. So option C is the correct answer for this question. You can solve the other way also. Okay. Is it fine for you? Okay. So nobody is answering. So moving to our next question. So our next question is again from the matrix itself. Um, so how many solution does the following system of a linear equation have? So linear equation is minus x plus 5y is equal to minus 1, x minus y is equal to 2, x plus 3y is equal to 3. So options are the option A is infinite many solutions, or option B two distinct solution, option C is unique, or option D is none. So can you answer or can you solve this question? So you can solve it in other way also. So one way is three equations are given, right? So you can make like equation 1, 2 and 3, or you can make a matrix of this one and then just use the matrix like addition, subtraction, this one, then you will get the rank, right, of this matrix, and then from there you can find out. So other way is directly equations are given. So if we add equation 1 and 2, then what we will get? Get add equation 1 and 2, you will get 4y is equal to 1. And here you will directly get y is equal to 1 by 4 or 0.25. Right? Now substitute this y value in equation 2. Then you will get x minus 0.25 is equal to 2, and here x, you will get x is equal to 2.25. Now x and y values we have got. Now we can put it in equation 3 and check whether this x and y values is equal to this value. So if it is satisfied, so this equation, so there will be a one solution, one unique solution will be there. Otherwise, if not satisfied, then we have to check the other also, I mean other values. So from there, it can be a many or infinite solutions will be there. Two solutions will be there. So just check x. We have got 2.25. Put x and y values in equation 3 and check this. So plus 3 into 0.25. So if you just multiply 3 into 0.25, you will get 0.75. If you add this one, so you will get 3. So this 3 and this 3 is equal. So that means there have only one and the unique solution will be there, right? So here option C is the correct answer for this question. Okay. Is it okay for all of you? Is it fine? Can we move to our next question? Okay. Okay. So now moving to our next question. So next question is, four pair coins are tossed simultaneously. The probability that at least one head and one tail turn up is. What is the probability that has at least one head and one tail at a time? So can you solve this question and answer in the chat box? Please try to solve this question. Then I will go through this question. Option A, okay, we will check. Yes, other, please solve it and try to answer in the chat box. So any one of you, can you tell how many total outcomes will be there? There are four coins are there, right? Here, four pair coins are there. So what will be the total outcome? So each coin has head and tail, right? Yeah, not correct. This is 60. So total outcome will be the 16. Okay, so how? Because each coin has one head and one tail, and there are four coins, so 2 to the power 4 total outcome that you will get when you are tossing these four coins is 2 to the power 4, that is 16, right? So in this 16 total outcome, so there are two outcomes where you will get all head and or all tails, right? There are two outcomes where we will get all heads. That means all the coins have heads only, or it can be a all tail, and all tails. That is right. So so that can be appeared. So total favorable outcomes will be, what will be the total favorable outcome, that is total outcomes, and we can say that this one is an unfavorable outcome because here we are getting the all head or all tail, right? So at least we need one tail and one head to get this, find out this probability, at least one head or one tail, right? So this is an unfavorable condition. We can say that outcome you can write. So here 16 minus 2, so 14. So total favorable outcome will be the 14 only. Okay. So probability of getting one head and one tail at a time or turn up, that at least one head and one tail, that is turn up, is favorable outcome divided by total outcome. So our favorable outcome is 14 and total outcome is 16, right? So if you just divide it, you will get 7 by 8, right? 7 by 8. So probability that at least getting one head and one tail when we are tossing the coins is 7 by 8. So option C is the correct answer for this question. Okay? Yeah, 7 by 8. Yeah, correct. Yeah, correct. Many of you have given the correct answer. Okay, thank you. So, have you understand this question? Is it fine for all of you? So, this is a basic probability question for your just recapitulation of the concept. Okay, so now moving to our next question. Now, next question is, a bag 1 contains 4 white balls and 6 black balls. Another bag 2 contains 4 white balls and 3 black balls. One ball is selected at random. from one of the bags and it is found to be black. Find the probability that it was drawn from bag 1. So, anyone, how to proceed with it? This question? Okay, I will wait just 1 or 2 minutes so that you can solve this problem, then I will solve it. Okay, so please solve it and try to answer in the chat box. Then I will go through this question. Screen, what's the problem? Is it fine? Please try to solve this question. Option D, okay. So here already given that bag 1 contains 4 white balls and 6 black balls. Okay, so what will be the probability of getting black ball from bag 1? So total number of black balls we have 6 black balls and total balls in the bag 1, right? So probability of getting black ball from bag 1, this one is represented by this one, is how many black balls are there? This is 6. So total black balls and overall balls in the bag 1. So here 6 by 10. Okay. Similarly, for bag 2 also, probability of getting black balls from bag 2. What will be the probability of black balls from the bag 1? So can you answer for this one at least? So in the bag 2, there are 4 white balls and 3 black balls. So what is the probability of getting black balls from bag 2? Yeah, 3 by 7, correct. Okay, so now solve to our next one. So what is the probability from selecting bag 1 or bag 2? There are total 2 bags, right? So each having the probability 1 by 2 getting selected, right? So we can say that it's prior probabilities. That is probability of getting selected bag 1 or probability of getting selected bag 2 is there are 2 bags, so 1 by 2 for each, right? Or I can write it clearly here, probability of selecting black balls from bag 1 or bag 2. Okay, so probability of getting black balls from bag 1, because here they have asked only what is the probability that black ball we have found, that is from bag 1. The probability of getting black balls from the bag 1 is represented by this one. I can write it here. Probability of getting black ball from bag 1. Okay. So by using the Bayes theorem, already you know that, I think. What is the Bayes theorem? So Bayes theorem is like this. Probability of getting black balls from bag 1, and what is the probability of the bag 1. Now the overall probability of from the both bag, probability of getting black ball from bag 1, probability of bag 1. Similarly, probability of getting black ball from bag 2, probability of bag 2. Okay, so this is a probability of overall probability of getting black ball from bag 1. Okay, so all the values we have here just calculated. So probability of getting black balls from bag 1 is 6 by 10 into probability of the selecting from bag 1 is 1 by 2. Here it is same 6 by 10 into 1 by 2 plus here 3 by 7 into 1 by 2. So now at least can you solve and answer in the chat box what will be the overall value? Can you solve this one? Where 2, 3, 6. So here you will get in the probability in the numerator part I by B, you will get 3 by 10. In the denominator again you will get 3 by 10 plus 3 by 14, right? Okay, so have you solved? Please solve it and answer in the chat box which option is the correct one. So here you will get to 3 by 14 here. I'm just directly solving it, and in the denominator you will get 72. Okay, so I'm just removing it from here so that I can write. So here you will get 42 divided by 72, and you will total, if you just divide it, you will get 7 by 12. Okay, so that is probability of getting black ball from bag 1 is 7 by 12. So this is the correct answer for this question. That is option D. Option D is the correct answer for this question. Okay, so have you understand this question? Is it fine? 3 by 7, someone is answering. Okay, for that one. No, right. So is it okay? Is it fine? Can we move to the next question now? Have you understand? Okay, so moving to our next question now. So the next question is the standard deviation of a uniform distributed random variable between 0 and 1 is. Option A is 1 by root 12. Option B is 1 by root 3. Or option C is 5 by root 12. Or option D is 7 by root 12. So Can you solve this question or try to answer? Screen is not visible, so is it visible? Any one of you? Can you check with your network issue? Because from my side, it is okay. Yeah. So just check your internet connection. So maybe. And for others, it is visible. So just try to answer for this question. So already we know that the uniform distribution here, because the standard deviation, they are asking standard deviation of the uniformly distributed random variable between 0 and 1. So already we know that the for uniform distribution, so it is represented by U, A and B. Please mute yourself, Lucy. Okay, so the variance of the uniformly distributed random variable is random variable is it is calculated by sigma square here b minus a whole square divided by 12. But here random variable is given, that is between 0 and 1 we have to calculate. So here a is 0 and b is 1. It is given. It is given in the question. So now just put here in the variance formula sigma square 1 minus 0 whole square divided by 12. Okay, so we will see. So here again 1 minus 0 is 1, 1 square is 1, so 1 by 12 you will get, right? So the here they are asking the standard deviation, but it is a variance. If we just take this one root, just remove the square part, so you will get the standard deviation, right? This is a standard deviation. So here you will get again root 1 is 1, root 12, right? So here again option A is the correct answer for this question. Okay. Okay, is it fine? So first we need to just check the variance of the uniformly distributed random variable. Already this one is a formula. We know that the variance is equal to b minus a square divided by 12. So here it is already given. We need to find out between the 0 and 1. So a is 0, b is 1. Just put the values and find out the standard deviation of that. uniformly distributed random variable. Okay. Okay. So now moving to our next question again. If a random variable x satisfies the Poisson distribution with a mean value of 2, then the probability that x is greater than or equal to 2 is, what will be the probability of getting x is greater than equal to 2? So what is the formula for the Poisson distribution? Anyone? Here the mean of the Poisson distribution is given, that is 2, right? So in the Poisson distribution, mean is represented by lambda, so that means lambda is given 2, and the formula for the Poisson distribution, that is, let's say it is represented by p of k, so it is e to the power minus lambda, lambda to the power k. K is the value that can be varied, and here k factorial, right? And how we can calculate? Probability of getting x would be greater than equal to 2. So it is 1 minus p x greater than probability of getting less than 2 values, 1 minus. So first we need to find out this value, then we will put into this. So how we can calculate it? So here x, so less than, so for less than 2, so there are x can be a 0 and 1 only, right? So if we put for two values, we need to check, right? So probability of x is 0, that is x is equal to 0, or we can say that p of 0, just put in this k is equal to 0 in this formula, so you will get e to the power minus 2, because lambda is equal to 2 is given, and 2 to the power 0, because k here is 0, in this we are putting, or we can say k or x divided by 0 factorial. So 0 factorial will be 1 only. So here you will get e to the power minus 2. Similarly, for p of 1 also, that means k is equal to 1. Here we are putting e to the power minus 2, 2 to the power 1, and 1 factorial. So 1 factorial again 1. So 2 e to the power minus 2. Right? Now we need to put, so in the more refined way we can write it this equation here, 1 minus in bracket p of 0 plus p of 1, because here we need only x less than 2 values, probability of getting x values that is less than 2, right? So just probability of getting x greater than equal to 2 is equal to 1 minus p of 0, we have got e to the power minus 2 plus 2 e to the power minus 2, right? So this will be added because this is same. So 2 here 1 always. So 1 minus 3 e to the power minus 2, right? You will get this one, 1 minus 3 e to the power 2, just if you add these two values. So if you check, that option D is the correct answer for this question here. This is the best matching from the answers. Is it fine for you? Is it okay? Have you understand? Already these are the basic questions, so I think all of you know that. Okay. So okay, now moving to our next question. Okay. So now next question is compute the derivative f dash x of the logistic sigmoid. So here we need to compute a derivative, that is f dash x, of the logistic sigmoid. So any one of you can tell what is a logistic sigmoid function? How we can represent it? Logistic sigmoid function? Anyone? If you know, please try to answer in the chat box, or either you can unmute yourself and give your answers. What is the logistic sigmoid function? Okay, so nobody is interested to giving answer. Okay, so the logistic sigmoid function is a sigmoid function. Let's say it is a, we can represent it to sigma x, and the derivative of the logistic sigmoid function is represented by this one. So options C. Already all of you giving answer. So just I have asked what is the logistic sigmoid function. The logistic sigmoid function is represented by 1 divided by 1 plus e to the power minus x. This is a logistic sigmoid function. Or we can also write it 1 plus e to the power minus x inverse, right? It is represented by sigma of x. Okay. So to find out the derivative of the logistic sigmoid function, we can apply the chain rule, right? Because it is in this form. To find the derivative, we can apply the chain rule, right? So the derivative of the logistic sigmoid function is represented by, let's say, f dash x, like d by dx sigma of x, right? We need to find out the derivative. So how we can find out? So d by dx 1 plus e to the power minus x of minus 1. So if you take the derivative using the chain rule, so you will get, so this one is first term minus 1, right? Then 1 plus e to the power minus x minus 1 of minus 1, right? Is it fine? And then because we are taking the derivation with respect to x, so first here it is a whole value of x, then t by dx 1 plus e to the power minus of x. Okay, so here we will get minus 1 plus e to the power minus x to the power minus of 2 into, so d by dx, here 1 is 0, right? And for this one, so again here the we are taking with respect to x, so again, so minus this one will come here, minus e to the power minus x we will get. Okay, is it fine how we are getting the derivative? So here you have got this one. So if you just, this is, let's say, one is simple multiplication, so minus minus will be plus only. So here e to the power minus x or 1 plus e to the power minus x to the power minus 2 you will get, or either we can write it e to the power minus x divided by 1 plus e to the power minus x whole square, right? We can write it like this one. Till now it is fine for you. Okay, so now we need to simplify this algebraic expression. Okay, so I'm just removing in this upper part, so that will be the easier. So I don't have a space here. I hope all of you have noted down. So can I remove it here from here? Can we try it because we require in the later. So if we solve this equation, so this function can be written like this. Can we write like this? 1 plus e to the power minus x into e to the power minus x divided by 1 plus e to the power minus x. We can write it because when we just breaking this one, 1 plus e to the power x whole square, 1 plus e x, 1 plus e to the power minus x in that form. So now if we add and subtract 1 in this numerator of this one, that will be the same, right? That will not affect this function if we add in this part, like 1 plus e to the power minus x minus 1. So if we just cut it down, the function will be the same, right? If we add and subtract 1 in the numerator, okay? So now, just I have to remove it from here.
The Blanca.
Okay, so here that we have got. So now further we can write it 1 plus e to the power minus x into, in bracket, we can write it 1 plus e to the power minus x, right, divided by 1 plus e to the power minus x minus 1 by 1 plus e to the power minus x. This function, this whole function, can we write it like this one, right? Because if we again just add these two, so we will get the same function, right? But if you check this, this will be the cancelled out here, right? So 1 plus e to the power minus x into, here we can write 1 minus 1 plus e to the power minus x, right? Now, what is it? Our function? This is represented by the sigma x, right? Already in the initial. So it is the same. So we can write it like sigma x in bracket 1 minus sigma x, right? We can write it like this. And that is equal to f dash x. That means the derivative of the that logistic function sigmoid. So this is the proof of this. So derivative of the sigmoid function is sigma x, that is 1 minus sigma of x. That is option A is the correct answer for this question. So is it okay? Have you understand this question or this explanation? Okay. Anyone have any doubt or anything? Okay. Nobody has any doubt. So now moving to our next question. So now our next question is related to the fundamental concept of the computer vision and image processing, basically the image processing. So what is the phenomena one encounters when a lens fails to converge all the wavelength of a light on the single focal plane. So which effect that will be there? So option 1 is magnetic effect, option B is chromatic aberration, option C is non-collinear vanishing point, or option D is distorted image. So what phenomena will occur when a lens fails to converge all the wavelengths of a light on a single focal plane? Anyone have any idea? Please at least guess here which option can be a correct one. Anyone of you? Okay, option B. Okay, right. Chromatic aberration. So yeah, okay, that's correct. Option B. So detailed explanation is there. So here we will see the solution. So first we will see what is a magnetic effect. So magnetic effect is the gradual darkening of an image towards the corner. Because if any image is there, so just darkening or making some towards the every corner of the image. So typically it is caused by light physically being blocked by the lens, barrel or other optical components where we are taking the images. So gradually like this one is any image. So just darkening the this part. So this is called the magnetic effect of the in the image. Now next one is a chromatic aberration. So this phenomena is occur when the lens fails to converge all the wavelength of the light onto a single focal plane. That is called the chromatic aberration. So it occurs due to the wavelength dependence of the refractive index of the lens's material, causing that cause different colors to focus on the different positions. So different wavelengths, that is color, we can also say colors, reflect from the different amount. So when they focus at the distance, different distance, that occurs chromatic aberration. Okay, so our next option is the non-collinear vanishing point. So this is a term that is used in the computer vision and geometry that is related to perspective projection and 3D scene reconstruction, that is not related to the lens aberration that is caused by the light dispersion. Now next option is distorted image. This is a general or basic term of the image that it is not related to chromatic aberration in the form of distortion, and this type like barrel or pin cushion distortion related to the magnification changing across the image plane that causing the straight line or appeared curved. So correct option from the above option is chromatic aberration because this is related occur when the lens fails to converge all the wavelengths on the single focal plane. So yeah, option B, that is second one is the correct one, chromatic aberration. Okay, so this one is the correct one, chromatic aberration. It is fine. So already it is given to you. You can see it. A detailed explanation is added here. So our next question is, what is the correct order of electromagnetic waves in terms of increasing frequency? So at least try to answer for this question. What is the correct order of the electromagnetic waves in terms of increasing frequency? So option A is microwaves, radio waves, then gamma rays or UV rays. Option B is gamma rays, UV rays, microwave, and then radio waves. Option C is first one is the radio waves, microwaves, UV rays, and gamma rays. Or option D is UV rays, gamma rays, microwave, then radio waves. Yeah, someone has answered already. Yeah, option C is the correct answer. Okay. Anyone else? At least try to answer for this question. Yeah, option C. Okay. Okay. Actually, they are asking in terms of the frequency. Okay, so there are two terms, wavelength, either wavelength or either frequency. So here they are asking in terms of the frequency, what is the correct order of the electromagnetic wave in terms of the increasing frequency. Okay, so just pay attention whether they are asking about the wavelength or the frequency. So here the solution is added here. So the electromagnetic spectrum is the range of all types of electromagnetic radiation that is ordered by the frequency or wavelength. So in the frequency increasing from the radio waves to the gamma rays, and in terms of when we are just order in terms of the wavelength, it is wavelength decreasing from the radio waves to the gamma rays. Okay. So the standard order for the electromagnetic waves from the lowest frequency to the highest frequency. Okay, so that is start from radio waves, microwaves, then infrared, visible light, ultraviolet rays, then X-ray, then finally the gamma rays. So highest frequency is for the gamma rays. So just we will compare the order from the given options in the questions. So here microwave they are asking, then radio waves, gamma rays, and UV rays. So this one is incorrect already, as we have the lowest frequency is the radio waves and highest is the gamma rays. So radio waves have a lower frequency than the microwaves and gamma rays has a higher frequency than UV rays. So this one is incorrect. And option B is gamma rays, then UV rays, microwaves, then radio waves. It is also the incorrect. This is or it's almost reversed. And option C is the radio waves, then microwaves, then UV rays, gamma rays. So this one is a correct order. The sequence correctly places the wave in the increasing order of the frequency, escaping the others in the spectrum. Okay. Now next one is the UV rays, gamma rays, microwaves, or radio waves. So this is order. This order is also jumbled. The correct option is radio waves, then microwaves, then UV rays and gamma rays. Okay. So yeah, option C. This one is the correct answer for this question. Okay. So now moving to our next question. So now our next question is for a given material, that is VRDF, given by rho theta I theta r is equal to 1 by 1 plus e to the power theta I, where theta is the angle made by the light direction with the surface normal and theta r is the angle made by viewing direction with the surface normal. Find out the value of the outgoing radiance and increasing radiance Li for theta is equal to 0. Okay, so now you are able to listen. Is it fine? Okay, just I increase the volume, so just check whether it is audible. Okay, So how we can solve this question? For a given material BRDF, that is material is BRDF, the function is given as theta I theta r equal to 1 by 1 plus e to the power theta I, where theta is the angle made by the light direction with the surface normal and theta r is the angle made by viewing direction with the surface normal. Then we need to find out the value outgoing radiance with the incoming radiance Li for the theta I is equal to 0. Yeah, many of you giving answer here. Okay, option A is the correct answer. Correct. So how you have solved this question? So can you tell others also how we can solve this problem? Yeah, option A is the correct one. Yeah, right. So how we can solve this problem? Okay, so let's see the solution here. So BRDF means bidirectional reflectance distribution function that describes how light is reflected from the surface. So for a given incoming radiance Li, the outgoing radiance L0 is defined by like incoming radiance is represented by Li and outgoing radiance is represented by L0, and that is represented by this one, this function L0 is equal to integration over omega rho theta I theta r Li cos theta I d omega I. Okay, so where already we know that this is a BRDF function rho theta I theta and Li is the incoming radiance, cos theta I that is accounts for the angle of incidence, d omega I differential solid angle and omega is hemisphere of the incoming light direction. And here differential solid angle is also represented by this one sin theta I d theta I d phi. So the given conditions, the BRDF function is given as rho theta I theta r is equal to 1 divided by 1 plus e to the power theta I. This function it is given in the question, right? This function. And also it is given theta I is equal to 0 with the incoming radiance Li for the, okay. So incident angle that means theta I is equal to 0 degree here. So here directly we can calculate the cos theta I because we need to put it here. So cos theta I that is cos 0 will be the 1 if we put. Already we know that cos 0 is 1. So when theta I is equal to 1, so the incident light is perpendicular to the surface. So if we put the e to the power theta I value here, that is theta I already given 0. So just we put in this BRDF function as well. So here we will get 1 by 2. So 1 in this just we need to put 1 plus e to the power 0. E to the power 0 is 1. So 1 plus 1. Here we will get 1 by 2. So this one is this. Now put all these values in the BRDF equation. Okay, so that means for the outgoing radiance we need to calculate. So rho theta I theta r Li cos theta I. So all the other values it is not defined, only the incoming for because we need to calculate for the outgoing radiance with the incoming. We are calculating for the outgoing radiance with incoming radiance Li and the angle is given as a theta I. Okay, so that's why all the other values are the not visible. So just put the all values here. So this function we have got 1 by 2 and Li cos theta I we have calculated here 1. So just putting in this equation. So here we will get L0 1 by 2 Li into 1. So L0 we will get 1 by 2 Li. Okay. So outgoing radiance L0 is 1 by 2 Li. Yeah. Option C. Oh, not. Here there is a mistake. Option A is the correct answer for that question. Yeah, mistakenly it is A. Okay. So option A is the correct answer for this question. Okay. So many of you have given answers. So I hope all of you know that. So is there any issue, any problem with this question? Or can we move forward with the next question? Any one of you? Is it okay? Okay. So moving to the our next question now. Now next question is, given a 5 watt source coming in from 2 pi by 3 solid angle in the steradian of a radius of 3 meter, the corresponding source of energy carried by the ray is. So here it is given that 5 watt source coming from 2 by 3 is not here solid angle that is in steradius of radius 3 meter, what the corresponding source of the energy carried by the ray is. Option D. Okay. So how we can solve this problem or this question? Can you answer for this one also? Then we will see the detailed solution here. So, okay, so let's see the solution. Here, the given data is radiant flux, that is 5 pi, that is a 5 watt source. Then solid angle is also given, that is omega represented by omega, that is 2 pi by 3 radian, and the radius is also given, r is equal to 3 meter. It is given in the question. So the radiant intensity, that is defined as a radiant flux per unit solid angle, that is I is equal to phi by omega. It is represented by the I is equal to phi by omega. So now all the values are given here. So just put in this equation. Phi is already given 5 watt. Phi omega is 2 pi by 3. So if you calculate the radiant intensity I, so that we will get 15 by 2 pi watt per steradian. Now next we need to see, here it is, the projected surface area corresponding to the solid angle, that is calculated by this formula. The projected area A is equal to r square of omega, where r is already we know that is a radius. So the surface area, the projected surface area is calculated by A, r square omega, where r is given, that is a 3 square, omega is also 2 by 3. So here 9 into 2 pi by 3. So overall surface we will get 6 pi meter square. Okay. Now next we need to calculate radiance is defined as a radiant intensity per unit area. We have to calculate, that is L equal to I by A. So A we have calculated, I is also we have calculated, just put in this equation, that is L is equal to I by A. So here L already calculated, that is 15 divided by 2 pi, and A is 6 pi. So now further we will calculate, so we will get 15 divided by 12 pi square. Now further we will solve it. So here we will get 5 by 4 pi square watt per meter square is the radian. So that is the energy carried by the ray. That is the energy carried by the ray. 5 divided by 4 pi square watt per meter square is the radian. Okay, yeah. Option D is the correct answer for this question. Okay, so is it fine? The solution, have you understand the solution? Is it okay? Anyone have, hope you have any doubt? Okay, so can we move to our next question? Okay, so moving to our next question. Now, next question is, which of the following accurately describes the Lambertian surface? So, option 1 is reflect light equally in all directions. Option B is reflects light only in the direction of incidence. Option C is absorbs all incident light, or option D transmits light without scattering. So, which option can be a correct one? Okay, option A. Okay, you are asking. We will see in the
Option
detail.
A.
Option A. Okay. Others, please try to answer for this question. At least try give a wrong answer what matters. Then we will see the detailed solution as well. Okay. Option B. Okay. Others, please try to answer for this question. Okay. Okay. So let's see the solution here. Okay. Awesome. Okay. Thank you. Thank you for trying for this question. Okay, the solution is added here. So, Lambertian surface, it is also known as a perfect diffuser reflector, and it is an idealized surface that reflects incident light such that the apparent brightness, that is also called the luminance of the surface, is the same regardless of the observer viewing angle. Okay, so this property is a result of the light being scattered equally in all the directions. Okay, that forms the hemisphere distribution of the radiant intensity. So this behavior of the Lambertian surface is described by the Lambert cosine law, which states that the radiant intensity, or you can say the luminance intensity, in a given direction from a point on a surface is proportional to the cosine of the angle theta between the direction and the surface normal. That is, I of theta is equal to I of 0 cos theta, and where I naught is the intensity of the normal plane, that is theta equal to 0. So the for the Lambertian surface, the key characteristic diffusion reflectance and constant luminance. So the diffusion reflectance is the light that is scattered in many directions, unlike a mirror specular reflection where light reflects at a single angle. And the constant luminance, that is because of the intensity decreases with the cosine of the angle, and the projected area of the surface also decrease by the same cosine factor when and viewed from an angle. So these two effects cancel each other out, making the surface appear equally bright from any viewpoint. Okay, so the real world example for the Lambertian surface is matte point, paper, or unpolished wood are the good approximation of the Lambertian surface. So the correct option is the option A, that is reflects light equally in all directions. Okay, so it is also known as a perfect diffuse reflector. Okay, so have you understand that option A is the correct answer for this question, that reflects light equally in all the directions. Okay, it is fine for you. Yeah, option A is the correct answer. Many of you have given the correct answer. Okay, okay. So now moving to our next question. Our next question is, so your night light has a radiant flux of 10 watt. What is the irradiance on your radiometry notes, which fell 2 meters from the light when you fell asleep, assuming your notes were perpendicular to the night light? Already started answering. Okay. Answer C is the correct. Have you tried or have you solved this question previously? So here for the night light has a radiant flux of 10 watt. Now we have to calculate the irradiance on your radiometry nodes, which fell 2 meters from the light when we will fell asleep. So any one of you, can you just try to answer how we can solve this problem? Then we will solve the solution here. Okay, so let's see the solution for this one. So to calculate the irradiance E due to point light source, so we will use the irradiance formula, that is E is equal to pi divided by 4 pi r square, and already the radiant flux pi is given as a 10 watt. Distance from the light source r is given as a 2 meter, and surface area of the sphere already we know that 4 pi r square. Okay, so to calculate the surface area, already r square value is given. Sorry, r, that is distance from the light source, it is given. So to calculate, so first we will calculate the surface area of the sphere, that is put in this one the r value. So here you will get 4 pi 2 square. So overall you will get 16 pi, right here. So this is the surface area. Now we have to substitute it into the irradiance formula. So already this is the irradiance formula. E is equal to phi divided by 4 pi r square. So if we put phi is given as a 10 watt and 4 pi r square, that surface area we have calculated, that is 60 pi. And already we know that pi is value is 3.14, right? So just put all these values. E is equal to 10 divided by 16 into 3.1416, and just take a multiplication of these two. So we will get 15.2526. And if we further divide it, we will get E is equal to 0.199. So the final irradiance is calculated as a 0.11199 watt per meter square. Okay, this one. So yeah, option C, that is this one is the correct answer for this question. Okay. So have you understand this question? The formula is given. We need to put. Already the values are given in the question. Just we need to remember the formula to calculate the irradiance E. Okay. So yeah, many of you have given the correct answer. Now can we move to our next question? Okay. So moving to our next question. The next question is, which of the following statement best describes irradiance? So option A is irradiance measures the intensity of the light at a point in terms of its wavelength distribution. Option B is irradiance is a power of electromagnetic radiation incident per unit area on a surface. Option C is irradiance is a radiant energy emitted by the source in all direction per unit time. Or option D is irradiance is a scattering of the light by particles in the atmosphere. Which option can be a correct one? Which of the following statements best describe the irradiance? Yeah, someone has already answered C. Okay. So any one of you want to try for this question? Okay, option B. Okay, at least try to answer. Then we will see the solution. Option B. Okay. Okay. So we will see the solution here. Which option can be a correct one? Which option is will be best describes the irradiance? Okay, so let's see the solution. So basically, irradiance is formally that is defined in a radiometry as a radiant flux, that is a power received by the surface per unit area, and the SI unit for the irradiance is watts per square meter. Okay, so the statement irradiance measures the intensity of the light at a point in terms of the wavelength distribution is incorrect because of this describes the spectral irradiance, not only a irradiance. Okay. Our next statement is defined as irradiance is a radiant energy emitted by the source in all directions per unit time. This one is also incorrect because this describes radiant flux or a power not per unit area, not necessarily only emitted energy. So the radiant flux per unit area emitted by the surface is called a radiant existence. And the one statement more that is described the irradiance is the scattering of the light by the particle in the atmosphere. This one is also incorrect that the scattering is the process of the effect that amount irradiance that reaches as a surface. So here the most accurate description is that irradiance is the power of electromagnetic radiance incident per unit area on a surface. So the correct answer is this one is option B, that is the irradiance is the power of electromagnetic radiation incident per unit area on a surface. Yeah, this option B is the correct answer for this question. Okay, so irradiance is the power of the electromagnetic radiance incident per unit area on a surface. That is the correct answer for this question. Okay. So now moving to our next question. Now, suppose a source with an area of 4 meters 4 per meter square is viewed at an angle of 30 degree and has a radiance of 0.3 watt per meter square per standard. radians, calculate the radiant intensity of the source. So how we can calculate the radiant intensity of the source? Okay, option D is the correct one. People are starting answering. Okay, so can you just tell me the formula how we can solve this question? Just try to answer for that one. How we can or what formula we can use to calculate the radiant intensity of the source? Yeah, okay, option D is the correct one. Okay, LA cos theta. Okay, okay, so let's see the solution here. So here radiance L is given as 0.3 watts per meter square. Area is also given. Okay, okay, no issues. Anyone else is facing from my side? Is it audible and visible, right? Okay, then it is fine. Okay, so here already radiance L is given, area and view angle is given. So the radiant intensity I, that is calculated by LA cos theta. Okay, so L value is given here, that is 0.3. A is also given, that is area is 4 meter, and the view angle theta is also given, that is cos 30. Okay, so 0.3 into 4, if you just multiply it, we will get 1.2, and the value of cos 30 is root 3 by 2. Okay, so further if we just divide it and take a value of root 3, the value of root 3 is 1.732. If we further multiply, we will get 1.0392. That is approximately equal to 1.04 we can write watt per standard radian. Okay, so yeah, this the formula is correct. The radiant intensity is calculated by L into A cos theta, where L is the radiance, A is the area, and theta is the view angle. Okay, so yeah, option D is the correct answer for this question. Okay, so now moving to our next question. So now next question is gray values of an image are. Option 1 is, so here different options are there. So option 1 is proportional to scene, radiance and for shortening factor. Second option is inversely related to the distance between the object and the lens. Option 3 is inversely proportional to the distance between the lens and the image plane. Option D is proportional to the total irradiance and unaffected by the Poisson factor. So the correct options will be, so which are the correct options will be there for this question? Please try to answer for this question. Which option can be a correct one? Okay, option A. Okay. So gray values of an image are. proportional to the scene radiance and foreshortening factor, that is inversely related to the distance between the object and the lens, inversely proportional to the distance between the lens and the image plane, or proportional to the total irradiance and unaffected by the foreshortening factor. So here the multiple options can be correct, either option 1 and 3, option 4 only, second and 4, or third and 4. Okay, so we will see the solution, detailed solution here in the next slide. Okay, so gray values in an image is determined by the irradiance of the at the image plane, which is amount of the light energy falling on the unit per in unit time. And this irradiance is governed by the several factors. So first one is a proportional to scene radiance and foreshortening factor. So image irradiance is a proportional to the scene radiance L, that is a foreshortening factor, that is cos to the power 4 alpha, or similar depending on the exact model and angle definition. And this accounts for the angle at which light is received from the object surface. So this statement is correct, proportional to the scene radiance and foreshortening factor. And option 2 is inversely related to the distance between the object and the lens. So image irradiance is generally considered independent of the object distance for the focused image. So assume that the object's angular size remains the same for the object field of the view. So this statement is correct. So inversely related to the distance between the object and this, it is an incorrect statement. Option 3 is inversely proportional to the distance between the lens and image plane. So image irradiance is inversely proportional to the square of the image distance and square of the effective focal length. That is f square for the distant object. So this statement is also the correct one. And now next uh, statement is proportional to the total irradiance and unaffected by the foreshortening factor. So already we have seen that it is dependent on the foreshortening factor. So foreshortening factor significantly affects the amount of the light captured from the surface. So this statement is incorrect. So option first and third is only the correct one. So from here, option 1 and 3rd is in the option A. So option A is the correct one. That is statement 1 and 3 is the correct statement for the gray value of an image. Okay. Okay. Yeah. Many of you have given the correct answer. Okay. So I hope all of you have understand. So now moving to our next question. So now next question is find the Euclidean city block and chessboard distance between the two. Okay, we will talk about, just let me complete this one is the last question. Okay, so now we need to find out the Euclidean city block and chessboard distance between the two extreme diagonal squares for the given patches. Okay, so here they have given that the two extreme diagonal square of the given patches. So this diagonal square it is given. So we need to find out the Euclidean distance, city block distance, and chessboard distance from the two extreme squares of the given, either this one, or this one, whatever value we can take. Okay, so let's see, just quickly just see the solution here to calculate the Euclidean city block and chessboard distances. First, we need to identify the coordinates. So here, the two extreme diagonals squares in a 3 cross 3 patches can be represented by its coordinate. So let's assume that top left square B. Let's see this one. Top left square, this one. Right bottom square is this one. We are taking this one and this one. Okay. So it is x1 and x2 we have taken, that is 0 0, and bottom right square, that is x2 and y2, let's say it is a 2 2. Okay. So the difference in the coordinate, first we need to calculate, that is difference in coordinate, that is delta x. Okay, so that is x2 minus x1 in the x direction, as well as we have to calculate for the y. So 2 minus 0, that is 2. Similarly, y2 minus y1 mod of, again 2 minus 0. So here we will get 2. So the formula to calculate the Euclidean distance, yes. So here we are representing the Euclidean distance, that dE. Okay, d here it is in the subscript. So the formula for the Euclidean distance is root of del x square plus del y square. So already we have calculated differences in the coordinates, that is del x and del y. Right here we have calculated. So just put in this formula, we will get 2 square plus 2 square. So 4 plus 4, 8. So d Euclidean distance we will get root of 8. That is, if you just calculate root of 8, we will get 2.82. Okay, ma'am, how did you take the coordinates? So, in the question, they have told that we have to take two extreme diagonal squares, right? In the question, extreme diagonal. So, I have taken this one and this one. You can take this one or this one. Other values also, either 3 3 or 1 1, like this one. If you calculate for that value, you will get the same answer itself. Either we can take this one, or this one, right? So you can take any one. So the equating distance is calculated. Root of 8 value we will get 2.82. Similarly, the formula for the city block, or it is also called as Manhattan distance, and here it is represented by D in subscript CB, that is city block. Okay, so the formula to calculate the city block distance is mod of del x plus mod of del y. So already the difference in the coordinates we have calculated, that is 2 to mod of 2 plus mod of 2, so it is 4. Okay, so the calculate the distance of the chessboard distance. So it is represented DCH, that is chessboard. Okay, so maximum of del x into del y, that is difference in the coordinate. So what will be the maximum value? That is 2. So the distance for the chessboard is 2. So the distance for the Euclidean distance is 2.82. For the city block, that is 4. And for the chessboard, it is 2. So just we need to remember this formula, this one. For the chessboard distance, for the Manhattan or city block distance, this is one. And the Euclidean distance we can calculate it by this one. Okay, so yeah, correct option is C, that is 2.82, 4 and 2. Okay, option C is the correct answer. So yeah, someone is asking, so here it is a 0 0, we can take 0 0. Here it is a 0 1, right? The value here 0 2. Here the value for this one 1 0, right? Here it is a 1 1. Here 1 2, like this. Here it is a 2 2. So yeah, you can take that 3 3 also. Then for that you have to take 3 3 and 1 1. For that one you can also calculate. So yeah, these are the explanation for that one. Now we have completed the questions for the this week. So now if you have any doubt, you can ask. Otherwise, we can close the session. Yeah, someone is asking something. Yeah, thank you, Priyadarshini. Okay, so we will upload this on the YouTube channel, yeah. And in the, I think in your portal, so in portal, there you will get live interactive session. One from there, you can get all the details like this slide, whatever questions we are doing here, and their YouTube video link that you will get. Okay, yeah, I will just copy it here. Yeah, ma'am. No, we have to take corner to corner. In the question, they have itself, they have told in the question, just read this question. So they have asked, find the Euclidean city block and chessboard distance between the two extreme diagonal squares. So what are the two extreme diagonal squares? This one, this, or this one, like two extreme, like this or this. Mostly this and this we have to calculate. So these are the two extreme diagonals. Okay. So here we need to take the corner to corner. It should be, I think, then 1, 1 and 3, 3. Because we are starting if 0, 0, because 3 cross 3 matrix, so 0, 1, 2, 3, right? If you are taking, then it will be the 4 cross 4 matrix, right? In that case. So only 3 blocks are given. I mean 3 rows and 3 columns. So that's why we are taking 0, 1, 2. Or either you can take 1, 2, 3. 0 to 3, not 0 to 3. Then in that case, it will be the 4 cross 4 matrix. But in the diagram that is given, it is a 3 cross 3. Only 3 rows and 3 columns are there if you just check. It is fine now. Why we are taking either 3, 1, 1, 3, 3 or 0, 0, 2, 2? Yeah, you can say either you can say that each square represents a matrix. Yeah, you can say each square has a length of 1. I mean, just there are one image is given, we need to calculate the Euclidean, I mean distances for the extreme square point. So just take okay, 0, 1, 1, 2, 2, 2, 3. Okay. So any matrix, just let me here. How any matrix is represented in the coordinate form? Either here it is a 0, 0, right? Here it is a 0, 1. Values here 0, 2, right? Here, what is this? 1, 0, 1, 1. Here it is 1, 2. Here it is a 0, 2, 0, 2, 1, 2, 2. Either, or we can represent in this form also 0, 0, 0, 1, 0, 2. Okay? Like here it is a, I mean 0, 1, 0, 2, 0. Like this one. Here it is a 1, 1, 2, 1. Here it is a 1, 2 and 2, 2. So here two extreme points, this one and this one, or either this one, this one. We need to calculate the two extreme diagonal squares. No, the coordinate means either x and y values, right? So each block represents the values, I mean in the x and y direction. Okay. Anyone else having any doubt? Any? So I'm just sharing it here. From here you will get all the details. Just a minute. So in this link, if you just open it, you will get all the details. I mean presentation folders, YouTube video links, and other materials also. If it is required, if you need any other help, also I will update here. Okay. So anyone else? Any doubt? Anything? So if you don't any, have any doubt, so we can close the session. So yeah, thank you everyone. Thank you for joining the session. We will meet for the next session for week 2 problem for the same day and the same time. I think my class will be the Monday 6 to 8 only. Okay. Okay. So thank you everyone. Thank you for joining this session. Now, if you don't have any doubt, you can leave this session. And if you have any doubt, then we can discuss. Yeah. Thank you. It is attendance sheet, but for all of you, how many of you have attended, but all the details will be there. How many people are attended, YouTube video link and content also, presentation material and questions as well. Okay, is there anything? So anyone have any doubt or we can close the session? Okay, so thank you everyone. Thank you for joining this session. We will join in the next session. Okay.